Hi everyone. So welcome to the Rocking DFT session. So today we are going to discuss something about the BIST architecture. Okay. So I'm just going to give you a brief overview about the BIST architecture. So BIST architecture can be classified based on the hardware, okay, in two main classes. One is called where the test pattern generation and output response analyzer, that is an ORA, it's also outside of COT. And the other one is called an embedded BIST, in which we are going to reuse the CUTs or the design and the test, the flip-flops or the latches as the test pattern generation generator or the ORA. So on the basis of the hardware, we can classify it into two main sections, TPG and ORA outside of DOT. And the second one is an embedded BIST where we are reusing the flip-flops and the latches as TPG and ORA. Then in terms of the clocking scheme also, we can classify the BIST architecture into two main sections. One is called the test per clock, okay, and the second one is called the test per scan. So in the test per clock, we are going to apply a test every clock cycle, test the pattern with every clock cycle, and another one in which we are applying a test in between the scan input and scan output. Okay, so this is in regards with the clocking scheme. So far, you have understood there are, in terms of the hardware and in terms of the clocking scheme, we have divided the BIST into the many classifications. Now, in the test per clock, okay, the main thing is that if you are using a test per clock, we have one architecture in which whatever the DUT or CUT is there, it would be combinational in nature, okay? So we would be using a separate BIST for it, okay? It's called a separate BIST concept, okay? And here we are going to apply a test per clock. And at each clock, we are going to apply a test pattern and we would be observing the output. But this is only for the combinational design under test. Okay. But it is good for the combinational CUT, but we won't be having only combinational stuff in our design under test. We would be having the sequential stuff as well. So what we can do in that case for the sequential DUT or the sequential CUT, we can we can actually use one very important scheme that is called the Bilbo architecture. It was suggested by Kahneman in 1979. So Bilbo is embedded based because here we are going to reuse the flip-flops and the latches of the DUT and CUT as your flip-flops, as your TPG and the ORA. So, Bilbo is having many advantages. You can see on your screen a Bilbo architecture. So Bilbo architecture, like for example, it's having like two inputs, B1 and B2, and we would be classifying into four main modes. One is then LFSR mode, second one is then miser mode, third one is called scan mode, and fourth one is the normal mode. Okay. So based on whatever how you are selecting the inputs like B1 and B2, you can actually go to any different mode. So this is a test per clock architecture, which is a Bilbo architecture. There are many pros and cons of Bilbo. The one main pros, what I can say is that it is very good for XP testing. And the cons are that if you can see from the hardware itself that if the area overhead is too large, okay, for a small circuitry, you would be requiring these many pins, this many kind of a combination and hardware architecture. So area is very hard and the performance overhead is also there. Okay, and Bilbo is an embedded BIST. Okay, so far we have learned about the test per clock. Now we can discuss something about the test per scan, which is here in the test per scan. The first architecture which has been introduced, it is only for the single chain. Okay, so you would be using an LFSR and which is going to generate the PRPGs for your DUT or the CUT, and then you would be using an output response analyzer to compact the signatures. Okay, but it is only going to have only a single chip in that kind of DUT if you have. But that is not for the case. Now we have many scan chains in our DUT or COT. So how we can solve this problem? So to eradicate this particular issue, there is one particular architecture which has been proposed by Bardell and McKinney, 1982. IBM, and this architecture is called the stumps architecture. And there's a full form of the stump architecture, which we are using today as well, the modified stump architecture. It's called self-test using a miser and the parallel shift register. Okay, this is the full form of stumps architecture. There are many advantages for this stumps architecture because it's having a small area and it's good for the multiple chains. You can just see the figure on your screen for the stumps architecture. Okay, and but the simple control is a very important advantage of this. There is a disadvantage as well. For example, because of this particular stumps architecture, you are going to take longer test time. Okay, than the test per clock scheme, what we have seen earlier. Okay, but there is a very important disadvantage for the stumps architecture. In the initial stumps architecture, that disadvantage was the structural dependency. Okay, and later on, in the later on, someone proposed how to eliminate this structural dependency with a very important hardware that is called a phase shifter. So the issue in regards with the structural dependency and why the phase shifter is required and how the stump architecture is being modified and what we are using today. So that we are going to discuss in our next video. Okay, so today we have just given a small glimpse on the BIST architecture, the small history of the BIST architecture. What are the different classifications of the BIST architecture based on the clocking scheme, based on the hardware, okay, different classification. In the test per clock, we have discussed the Bilbo is the main architecture which has been used, but there are many disadvantages associated with that. Then in the test per scan, the stumps is the main architecture. In the initial architecture, we were having an issue with the structural dependency that has been eradicated later on with a phase shifter kind of a concept. Okay, so we'll discuss all these things in our next lecture. Okay, so thanks a lot. Give your feedback and enjoy the Rocking DFT channel.